Okay, for a retake, you gotta watch this 17 times. You gotta know your crap on logs and compound interest. Number one is compound interest. So, the money that you can expect to have in your bank, let's call that Y, is equal to whatever you deposit times 1 plus the rate divided by n. That's the number of times you compound it. And then the exponent is going to be n times t. T is how many years you're leaving in the bank. So your grandma leaves you an inheritance of 16.5. You're going to invest it 6.5% compounded quarterly. That means n is 4. You're now 20 and you're wondering how much you're going to have. You're going to retire at 65. So t is equal to, you put it in at age 20, you pull it out at 65, t is equal to 45. So, the money you're going to have is equal to 16,500 times 1 plus, okay, the rate. The rate, you've got to change that to move the decimal 2 times to the left, so it's 0.065 over how many times it's going to pay you interest. It's going to pay you interest 4 times a year, quarterly. Then your exponent is going to be 4 times 45. So you just type that in your calculator, as is. Oh, let's see, I got an answer key. Okay, so Y is equal to 300 grand, 320 bucks, 16 cents. Okay, now B, broker tells you if you will up your deposit to 25 grand, so that's the P, rate of 9%, that's the R, compound continuously. Continuously means you're making interest every second of every day. So if it's continuous, it's a different formula. It's principal times E. That's where E comes from. E comes from continuous growth or continuous decay. Times R times T. So that's going to give Y, which is the amount of money you're going to have. So here we go. Y is equal to 25 grand times E to the 0.09 times 45. Still the same amount of time, 45 years. And the amount of money you're going to have is $1,000,000, $434,936 43 cents. Okay, number two. Okay, you got a formula, and all you got to do is know what to plug in where. So this T sub 0, that's the initial temperature of the object. Mom pours a bowl of soup right off the stove. It's hot. You burn your tongue. It's 205. That is the initial temperature of the soup. Okay, use the value 0.029 for K. So that's going to go in right there. Find the temperature of the soup to the nearest degree after 10 minutes. 10, that's time. That's our T. The room temperature is 74. That's T sub S, temperature of the surroundings. 74 goes there and there. So the temperature of the soup after 10 minutes is going to be T sub S, 74 degrees, room temperature, plus temperature of the soup, now 205, minus the room temperature, 74, raised to the, since it's cooling, it's getting colder, it's going to be a negative. Okay, 0.0296 times 10. Okay, there's your formula. So all you do is type that in exactly as it is on the calculator, and your temperature ends up being 171 degrees, 0.4. Okay, now B is a good question. When is the temp going to be 100 degrees? So that's, I want to know how long is it going to have to cool down. If the room temperature is 74, how long is it going to have to sit there for it to cool down to 100 degrees? So 100 degrees equals 74 plus 205 minus 74 to the negative 0.0296 times, now this is time and this is what we do not know. That's what we're trying to solve for. So I'm going to solve for t. So it's just an equation. I'm going to start undoing everything that's hanging out with t. So first, I'm going to ditch this 74. Minus 74, minus 74. Okay, 100 minus 74, that's going to be 26 is equal to 205 minus 74. I'm going to clean up the parentheses. That's 131 raised to the negative 0.0296 t. So I'm going to, I don't think I can ditch anything else. Okay, I can just ditch the 74, that's it. So now, I need to get t by itself, but t is hanging out with this negative 0.0296, and t is hanging out with 131, and 131 is the base of an exponent. And the only way you can undo exponents is logs. So right now, I've got to take this and morph it to a log. So it is going to be log in base 131 of 26, and that equals a negative 0.0296 times t. Okay, now I can get rid of the negative 0.0296 times t. I'm going to undo the times, so I'm going to divide by negative 0.0296 on this side. And this log, you just type it on the calculator, log base 131 of 26, hit enter, then divide that by negative 0.0296, and that gives you t is going to be almost 55 minutes, 54.6 minutes. Okay, number 3. Let's solve for x. And this is what you got to remember. Log in base e is equal to ln. That's the natural log. Okay, I'm going to undo this divide 2. I'm going to times by 2. Times by 2. So you got this. 2 times e to the x plus 4 equals 8. Okay, I'm going to undo this plus 4. Minus 4 minus 4. You've got 2 e to the x equals 4. Undo this 2. Divide 2. Divide 2. So I've got e to the x equals 2. Okay, now they want you to solve for x. They want you to get x by itself, and x is hanging out with a base of e, and the only way to undo a base is a log. So it should be log in base e of 2 equals x. And log in base e is the same thing as ln 2 equals x. And that is the same thing as this. So you just reverse the order. You put the x on this side and the ln2 on this side. So 2 is the number that must be dragged and dropped into that empty box. Okay, number 4. Expand the log. Log in base 6 of 7. Okay, divide. This single log I'm going to rewrite as 2 logs. Divide is linked with subtraction. So it's going to be log in base 6 of 7 subtract log in base 6 of 12 to the 5th. Okay, there's one more rule. If you ever have an exponent, you need to take it out and put it in front of the log, and it's timesing. So it's going to be log in base 6 of 7 subtract 5 times the log in base 6 of 12. Carlos! And that's your answer. Number 5 has been written out as the sum of 3 separate logs. We're going to combine them down into one single log. So first move, I'm going to take this 6 and put it up here as the exponent. So it's going to be log in base 5 of 2 plus log in base 5 of 4 plus log in base 5 of w to the 6. Okay, now logs, they all got the same base, and you're adding. So addition is linked to multiplication in powers and logs. So I'm going to take log in base 5 of this portion, the 2, times this portion, the 8, times this portion, the w to the 6. So it is going to be log in base 5 of 16 w to the 6. Okay, number 6. this is continuous growth or continuous decay, and that is almost the exact same formula as continuous compounding interest. So continuous compounding interest, principal, times E, times the rate, times time. And if it's growth, exponential growth or decay, it is going to be y equals, they call it A. That's the initial amount. That's the same as your principal. It's what you deposit. It's what you start with. Times E. And their rate of growth is called K and T. So if it's something that is decaying, K is negative. Something that's growing, K is positive. So here we go. 2007, the population of Georgia was 10.24 million people. 2000, it was 7.56. So it started in 2000 with 7.56. That is my initial value. That's A. Determine, we're going to find the rate of growth. So if I know what it started with, and I know what it ended with, and I know the time period, the time that happened over 7 years, I can figure out how fast it changed. So here we go. Okay, the amount, this is what you end with, this is what you start with. So I know both those, and I know the time is 7. So I ended up, in 2007, I ended with 10.24. I started with 7.56 times E raised to the K. I don't know what that is, but I do know the T. I know T. T was 7. Okay, now let's solve for K. I gotta ditch all this. I gotta ditch the 7, ditch the E. I'm gonna ditch the 7.56 first. So instead of times 7.56, I'm gonna divide 7.56. Divide 7.56. So 10.24 divide 7.56. Okay, I got this. 1.35447 is equal to E to the 7K. Now the only way I can undo, I can't ditch the 7 first, I gotta ditch the base. And the only way you can undo a base is a log. So I'm gonna do log in base E of this 1.35 blah 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 is equal to 7K. And now I can ditch the 7, divide this by 7, do this on your calculator, divide it by 7, and that will give you K. K is 0.04334. Now you're going to have to know that to answer B, because B, so let's say this rate of growth continues as it has the past 7 years, and let's use that to predict future growth. So let's predict when the population is going to reach 12K. That is the ending. So 12 million is equal to the starting. Started with 7.56 times E, and I know my K is 0.04334. This time I don't know the time. Hey. Alright. Pause. I can't remember where we left off. So, B. When's it going to reach 12 million people? Oh, we got it already set up. So, solve for T. Ditch the 7.56. Divide by 7.56. Divide by 7.56. And then you have E all by itself with this 0.04334 times T. Solve for T. The only way you can ditch that stuff is do a log. So it's going to be log in base E of whatever that number is, 12 divided by 7.56 equals 0.04334 T. Solve for T. Divide by, ditch this 0.04334. So that's times. So undo the times, divide by 0.04334 on both sides. And you should have time is going to be almost a little 10.5 years, 10.7 years later. Okay, 7, solve for X. Undo the minus 3. Plus 3, plus 3. 2 times e to the 3x equals 8. Undo the times 2, divide 2, divide 2. E to the 3x is 4. Only way you can ditch the 3 and the e is to log. So change to a log. Log in base e of 4 equals 3x. Okay, log in base e is the same thing as ln, so you got ln of 4 equals 3x. Ditch the 3, divide 3, divide 3. So ln 4 goes here, and ln 4 divide 3 is the same thing as, whoops, divide 3, 1/3 times ln of 4. So timesing by a fraction or dividing by 3, that's the same thing. So 1/3 is going to go there. Okay, number 8. So the same thing. What you end up with is what you start with times e to the growth rate times time. So certain bacteria is growing. It's telling you it starts off with 80. So that is the starting amount. There's 80 cells. That's the ending. 500 cells, that's the time. And they want you to find K. So 500 equals 80 times E to the K times 25. Ditch the 80. Divide by 80. Divide by 80. So you have got 500 divided by 80 equals E to the 25K. Now the only way you can get K by itself is you gotta ditch this E. The only way you can ditch the E is do a log. So it's gonna be log in base E of 500 divided by 80 equals 25K. Now you can ditch the K. Or ditch the 25. Divide by 25, divide by 25. Do all this on your calculator, you should have K is going to be 0.0733. Okay, so that's a big deal. Now you got to use that to find B. Here we go. So K is 0.0733. And when is the bacteria going to reach population of 6 grand? So that's the ending amount. So 6 grand is equal to the starting amount, 80, times E to the K, and I know that from problem A, 0.0733 times T, and I just don't know T. So let's start solving for T. Ditch the 80. Divide by 80, divide by 80. So you got 6 grand. Divide by 80 equals E to the 0.0733 T. Now you gotta log it. So it's gonna be log in base E of 6 grand divided by 80 equals 0.0733 T. We'll get T by itself, ditch the 0.0733, divide by 0.0733. So divide whatever that is by 0.0733, and you have time is going to be almost 59 minutes, 58.9 minutes. Weston Shipley is a good man. He loves fruits and dogs. Okay. 9. Solve for x. You gotta ditch the 5, you gotta ditch the e, ditch the 2 first. Divide by 2, divide by 2. E to the 5, x equals 12. Now the only way you can ditch the 5 in these, you gotta do log. So it's gonna be log in base e of 12 equals 5x. Now ditch the 5, divide by 5, divide by 5, whatever that is. You punch it in and you should get 0.49698. 10 log and base c of x minus 6 is 1. You guys finish your trig stuff. Get your trig stuff out, finish it. Okay, x is tied up into this log. The only way you can undo it is to morph it to an exponent. So it's going to be e. You need a base, you need an exponent, you need what it equals. That's the base. E to the 1 equals x minus 6. Ditch the minus 6. Plus 6 plus 6. So you do on your calculator e plus 6. And you have x is equal to like 8.718. 11. It's the same thing. That's log n base e. ln is log base c. So we're going to go e to the 7 equals negative 2x. Divide by negative 2, divide by negative 2. So on your calculator, e to the 7 divided by negative 2. X equals negative 548.3166. 12 plus 3 plus 3, 2. E to the x equals 4. Divide by 2. Divide by 2. E to the x equals 2. Morph it to a log. Log base e of 2 equals x. Punch that in your calculator. You should get x is about 0.49698. Okay. Number 13. You got log n base 4 of 5. Change it to a common log that is base 10 and change it to a natural log that is base e. So log n base 4 of 5, log base 4 of 5. Let's change the base 4 to base 10. So it's going to be log base 10 of 5 divide log base 10 4. So you take this one, it goes on top. You take the old base, goes on bottom with the new base. Same thing if you want to change these to base e. It's going to be log n base c of 5 divided by log base e of the old base 4. That is b. And that is it.